Welcome back everyone. My name is Sagar and we are back here with another video. So today is day 187 of our POTD series and this question's name is find the longest string and this is given a medium level question. So this question is very easy and constraints are so simple that this will be accepted with our brute force approach. So first of all we are given an array of strings. So first of all this is a string ARR and of length n, right? So you have to find the longest string which is lexicographically smallest and also all of its prefix should be present in that array. So that means we have to find that longest string that have maximum length and all the prefix. So that means if this is the longest string, so it have a length of 3. So this is the longest in all of our array. And in that case, we have to also check all the prefix of this string should be present in the array. So that means A is a prefix of this string, AB is also a prefix of this string. So we have to check whether A and AB is present in this string or not, in this array or not. And the optimal way to check if some particular string or some particular thing is present in a collection is by using a set, right? So we can use a set and we can just check if that thing is present in our collection or not in of one time. So first of all, we will create a set of this string. So that is our brute force approach. That is the first thing which comes to your mind, right? So first of all, we will just all add all the string to our set. So set dot add this as. So now all strings are added to our set, and now we have to check all the strings one by one. That if we are checking AB, so first of all we will check if this is the maximum answer. So we will create a string answer that will store our maximum value, maximum length, and also with minimum lexicographically order. So we have to check these two things that this should have maximum length and also lexicographically smallest, right? And for one particular string, we have to check if all the prefixes are present or not. So first of all, we will traverse and we will get a string s, and we have to check if this particular string is present or not. So all the prefix, if all prefix, or first of all, we can just check if this string have a length greater than or equal to our particular answer. So if this string, if this AB have a length smaller than our particular answer, then we don't have to check it again. So first of all, we will check if as dot length is less than our answer dot length. So that means our answer already have a greater length. So that means we will not check this string and we will continue. So this one condition will just optimize our solution a little bit more. And after that, else in else case, we will check if all the prefix in this string is present or not in our array. So in our array, that means we have to check in our set for optimal searching, right? So we will check for this s, that is all the prefix of this s is present in the set or not, and if all are present, then this will return us true. So we will be in this condition, and now we have to check if this string have a greater length or equal length. So if this string s have a greater length than our answer, then that means we just have to update our answer because this string s have a greater length. So our answer equal to s. Else if it have a equal length, so else if, or you can just directly say here else because less than condition यहाँ पे cover होगी थी हमारी, right? So that means we have to just write here else, and in else case that means s dot length is equal to our answer's length. So that means we have to check if our s is lexicographically smaller than our answer, and for that we have our method s dot compare to. So here it is a compare to method, and that will return us a number. Either that number can be 0, or 0 means that s and answer are equal, lexicographically equal. So the both strings are now equal. But if it return us a negative number, that means this number is smaller, and if it return us a positive number, then that means this number is greater. So we have to check if s is smaller. So if that returns, so if this method returns a negative number, so that means this s is a smaller number. S is a smaller string. So if s is lexicographically smaller, so we will just update our answer. So that is it. And at last we will return our answer. And we will also create that all prefix. And here we just have to traverse in our array to check all the prefix values from 1 to I should be less than n. And what we have to check, we will create substring sub equal to s dot substring of 0 to I. So first of all 0 to 1, that means it will create 0 0, then that means first of all it will create A, then AB. So let me just check if not sub dot set dot contains this substring. So if that substring is not present in our set, that means we have to return false. So all the prefix of this s is not present in our set. So we are just checking in this condition, and if all are present, then after this loop we will return true. So that is it about our algorithm, and the time complexity is n into length of our string. So n is 10 to the power 3, and the length of our maximum length of our string can be 30. So we can say that this is I think of n solution approx we can say, because this have a maximum fixed length of 30, and that can be 30 into n. So what is the problem here? N. Okay, we have to write here s dot length, and return what we are returning answer. So that's it. Let's check it. Okay, so our answer is correct, and the time complexity is approx of n. So this is our accepted solution, but this is a brute force solution. So now today you have to learn a new concept, and that is a trie. So in our POTD series, we already did some questions on trie based on trie. So trie is a data structure that is like tree, and we have to use that to store our string value character. And let me just tell you how a trie looks like. So first of all you know what is a tree. So there is this node, and there is this children nodes of this tree, children of this node, right? So that is something looks like a tree. But in our trie, so what we have to do? So first of all, we have to store our characters. So we will just store our character that if we have some strings. So remember that thing. If we have some string cushion, then you must refer to using a trie. So trie is a very optimal data structure for solving questions on based on our strings. So first of all, we have string A, B, A, B, C, and suppose this is our example. So we are given three strings. So using a trie we can also optimize our space using a trie. So first of all this is A, so we can say this is AND. So we will also have a variable here that will tell us whether this node is the AND or not. So yeah, so first of all we will say that this is the AND, or I think we have to use here, right? So just suppose for example, I have to let you know about this concept. So first of all, this is our node, right? And we are just adding our string A. So this is our AND. So we will just say AND equal to true. That this node is the AND of one string, AND of any string. So this A is the AND, and after that we have A, B. So we already have A in our tree, and after that we will just add another node that will contain B, and that is also AND. And after that we will have ABC. So this string is also added, and after that this string ABC. So we already have A, then we will move to next character, and this is B. So we also already have B. So what we will say, we will just add another character, another node, that is here C, and that is also last character. So we will also say this is AND. So for our ABC string, we can say E is the and B is also and A is also AND. So all the nodes that is in the path of this whole string are ANDs. So that means this whole string have all of its prefix present in our array. So that is how we have to create a trie, and let me just tell you how we can create it conceptually. So first of all, we will create a node, and what a node will contain. So first of all, you can see we are writing A, and after that its children is B, but B is not the only children. So we also have A as a children, but this have no value. So first of all, initially it will be null, but it is reserved for our A value. That if there is some A value A, so it will be here. So we have a value for A, value for B, a node for B, and let me clear it. And this is our A, and in this node also we have all the 26 character stored or reserved. So A, B. So initially this is null because there is no B, there is no string that is starting with B. So initially this is null, and also for C, but initially also this is null. So A to Z, we have all the characters reserved value in this node, in every node, right? So first of all, and also from A we have a next character as C, that is also initially null, D and up to Z. So we are in one string, but we have 1 to 26 stored sequence. So let me just write it clear. So first of all, we are creating a node that have a 26 length array. So this is our one node in our trie, and that have 26 character A, B up to Z. So this is an array of length 26. But what is the one value in our array? So one value in our array is another node. So this is our one node, and after that we have another node that have also 26 length array of nodes, right? So A, B, C up to Z. So after that, this is the same thing. So B will have 26 length array, that is of A, B, C and up to Z. So if we have some string A, B, C, so suppose this is our string. So first of all, we will say this is now not null. So rest of the things will be null initially, because there is no other string that is starting with B or Z. So when we have ABC, so we have first character A. So we will just say this is now not null, and after that second character is B. So we will just move to its children and we will say B is not null. And after that we will have C. So we will move to B's children and we will say this C is not null. And we know that this C is AND. So AND character. So we will say AND equal to true. So this one particular character, what it will have? So one particular value of this array, this will have either this is AND. Okay, we can just integrate that with our tree node. So our one tree node will have 26 length array plus also one different thing that will tell us either some character is ending on ending or not, right? So when we have A, so suppose when we have A only, so when we have A, so suppose this is the only character, and we will just say A is now not null, and we will move to next children. So that means we will move to node, we will move to children node of A. So we will move here in this tree node. So there is this tree node that is corresponding to A. So this whole tree node is corresponding to A, and we will say A equal to true. That means this is the end character. This is the end node, right? So I hope now you are getting my point. If the A is the only character, then we will say this is the end node of some particular string. And that is the thing we are creating. We are going to create. So this is our tree node that have two things. Array of 26 length of nodes. And this is a boolean that we will say. So let me just clear it. First of all, we will create our class. So a class that is trie node, and that will contain two things: boolean array. Oh no, this will create a boolean variable that will tell us either it is the end or not. And we have another variable that is our 26 array of length 26, that is of trie node. And we will just name it ARR. I think that's not a good name. We'll just call it node. And in our constructor, we'll just initialize these two. So first of all, initially end will be false. We don't have to say this is the end. And for our node array, okay, I think that is the simple name. So let me just keep it. So new. So that is it. So this is how we are creating a node. So first of all, we are creating a node, that is a node that will contain two things: is end variable and a array of length 26. So a array of length 26 from A to Z, for A to Z. So and after that we also have one another variable that will tell us either this is the end or not. So let me just initialize it. I can just create some helper method, so that's why I'm creating it globally. So after that, what we have to do, first of all, we have to insert all the strings in our trie, and then we will check either this is the maximum or not. So first of all, for all strings in our array, we have to insert. So I will just create an insert method for our try node. So we will just insert this as. So let me just create that method. That is void method. So we have to add some particular string character by character. So suppose we have A, B, C. So first of all, we will get this A and we will just add it here. And so I will just get character array and we will just get the index. So if we have to add A, so we have to add it on the 0th index. So first of all, we have to get the character. So we have to get the index. So index will be equal to C minus A. So if the character is there, then it will be added at 0th index. So after that, we have to first check if this character was already present or not, right? So suppose if before ABC we have A. So if we have A, then we will just add it to here. So this will be not null. But when we are checking for this, we cannot just update it. We have to first check if this was already present or not. So we have to check now if, okay, we also have to take here our current that is initially equal to root. So that will be our reference. That is how we have to iterate in our linked list. So this is some linked list like thing, and just imagine it like this. So first of all, if currents this index is equal to null, so that means previously this character was not added. So that means we are checking for A. So suppose there is this initially this ABC. So we are checking for A. So if this is our root node and this is also our current node, right? So this is our root and this is our current. So first of all, we are checking for A. If this 0th index of our current node is current current dot node current dot array. I think we should name it as array. So current dot arr. So we are checking in currents array that if this index value is equal to null. So if this index value is equal to null, that means we have to create here another node. So we will just create a whole new node from this A. So if it is equal to null, then that means current dot array index equal to new try node. So we will just create a new try node and you can see it is a try nodes array. So that means one value will be equal to a new try node. So we will just create a one new try node and after that we will just move here, right? So we added just a new character A here and after that we have to move to next character B. So we should be here in this node, right? So what we will do, we will just say current equal to current dot this. So that is something like when we do in our linked list current equal to current dot next. So that is something like this. We are doing here current equal to current dot next. So current is initially here in. So let me just clear it and show you. So we just created a new node corresponding to this A and current is initially pointing to here and what we are saying here current equal to current dot this value. So current equal to what is the new value of this current variable? It is equal to current this value. So this value is equal to here. So this value is just a new try node that we previously created and we will just move this current to here. So current is now pointing to this array and that have all of its empty value. And now this node, so this is our new tree node that is corresponding to A. So if we have only A as our string, so this can represent our null. This can represent the end of our node. So if this variable is equal to true, that means this A is a string that was previously present. So we have this is a node, so we have array and a variable. And current is now here. So after that, after this loop, but we will say current dot is and equal to true. So why am I doing this? So let me just show you. So first of all we are at this A. So we will create another try node and we are just here. So current is now pointing to here and this node is now corresponding to A, right? So after that we have B. So we will just create here B and a new try node corresponding to that and after that current will move here. So now this node is corresponding to B and that is showing AB, right? So that is showing AB and after that we have to move to C. So let me just clear it a little bit. So after that we are at C, and current is also not here. Current is here. So current is here, and after that we have C. So we will just create a C, and we will just create another node corresponding to that, and we are creating a new node that have array and is add variable, and current is now not here. Current is now here. So after that, what it will say, this array, this node will be corresponding to A, B, C. So you can also track the path. This is the previous character C, this is the previous character A, and the previous to this is A. And you can see C, B, A. So this is corresponding to the path is A, B, C. So you can see this node will represent A, B, C. And now we have to say we traversed in our whole string, and after that we are at here. So current is pointing to this node, and we just added our string. So that means after this loop, when we ended our string, we have to say current dot isEnd equal to true. So that means current dot isEnd. So this variable will be equal to true, because we know that this is ABC and this is a node. This is a string in our array. So this is a valid string. So that is why we are saying here current dot isEnd equal to true. So after we added all the strings in our tree node, we have to check. So for all the strings in our array, we have to check if is present. So we will also create a helper method. So if all the previous strings are present or not, so if all the prefix of this particular s is present or not, so we will also create an answer that will be initially empty. So if it is present in our, so this loop is exactly like what we are doing in our set. So just we are doing in here in this time, we are just doing it on a try node. So we are checking now try node that all the prefix of this s is present or not. So if all the prefix is present, then what we have to say, we will just check the same condition that we were previously checking. So okay, we were previously checking that if this s dot length is the length than our answer dot length, so that means we will just continue, and else else we will just check if. So that is for simplicity, you can also write here else if directly. So if s dot length is lesser than our answer, so our answer already have a greater length, so we will not check for this one, and we will continue. But if s have a greater length or equal length than our than our answer, so first of all we will check if this s is have all the prefix present in our try node or not, in our try tree or not. So if it have all the prefix present, then we will check if s dot length is greater than our answer dot length. Then we don't have to check anything, answer will be equal to s directly. And else if s dot length is equal to answer dot length, so if they have both length and answer also have all the prefix present in our array, and else also have all the prefix present in our array, and they also have equal length, so first of all we have to check which one is smaller or larger. So if s dot compare to answer have a negative value, so that means if it is negative, that means the s have a smaller value, so s is like geographically smaller, so answer will be equal to s. So that is it, and at last we will return our answer. So that is the only thing we have to do, and I hope now you understand this thing. So first of all, we are only remaining with this is present method. So this is also, I think this is void boolean. So this is boolean. So for checking a particular string that is present in our array or not. So we have, so let us just take this example and create a try node. So AB. So that means we are at here A, and so this node will represent A, and after that we have here B, and then we will be here. So this will represent AB. This node will represent AB, and this also have a variable that will that will tell us either this is end or not. But we can say here this is AB, so this is end. So after this loop, we will just say current dot is end equal to true. So that means this will be also true. So this is also end, and this is also end of some particular string. And after that we also have A. So when we have A, so this will be also considered as end, and we have ABD. So AB, and after that when we are at here B, so when we are at AB, so we will also create another we can say node that will represent D. So we will create another node that will represent D. So this will be A, B, D. And this is initially empty, and this also have a variable. So ABD is also added. So we will just say this variable is equal to true. So that is it. So this is empty, and I think that is it. So this is also add, and this is also add. ABC is also add. AB is also add, and A is also add. So that is it. Our four strings, and after that, what we have to check? We have to check if all the prefix of some particular string is present or not. Suppose we are checking for ABC. So first of all, we have to check either A is the end, or when we are at AB, so we have to check either AB is also end, and when we are at ABC, we also have to check ABC is also end, and that is obvious ABC will be end because that is the string. So when we are iterating over a particular string, we have to check all the characters, all the paths, all the tree nodes in between the path of this node. So first of all, we'll just create a try node. So try node that will represent our current equal to root. So here this is root, that is static, and after that we have to check all the particular characters. So like we were doing in our insert method. So first of all we have to get the index. So C minus A is the index, and we have to check. Okay, so we have to check if current dot arrays index equal to null. So suppose for an example, if okay, that can be not null, right? So that is obviously not null. If we have ABC, so A will be also present, B will be also present, C is also present. So we are checking for ABC, so this can't be null. So that is not any case. So when we are checking, so first of all we have to move to our A, then we have to check either A is the end or not. So first of all we have to move current equal to current dot arrays index, and we have to check if current dot is end is equal to false. So if current is not equal to is if the current is not the end of any particular string, then we have to return false, and else we have to return true. So let me just dry run this thing. So first of all, when we have ABC, so we are checking for ABC. So current is initially here. So current is initially at root, right? And after that, we are checking in every character. So A, B, C. So first of all, A, then B, then Z. So A. So we have to check. We have to get the index of A, that is here 0. So this is our 0th index, and what we are saying current equal to current 0th index node. So current will be equal to what is the 0th index node? 0th index node is this. So current will be here. So current will now move to this node, and what we are checking if current dot is at equal to false. So is current dot is end. So we are checking for this variable. This is equal to false. No, this is equal to true because this is the end of our previous string. So this is true. So we will not hit this condition. And after that, we will just move to our next character. So our next character is B. So we will just move this current to B's node. So current will be not here, and current will move to this node. And after that we will check if current dot is and equal to false. So we will check this variable, is this variable is equal to false? No, this is true. So that means this was also the end of any string. And after that we will move to next character. So our next character is C. So current will get the node of this C, and it will move to this. So current will be now moved to this particular try node. So current is now here, and after that, what we have to check? We will check if this variable have end equal to false or not. So if this node have end equal to false, no, it have true. So we will not hit in this condition, and our loop will end. So we will return true. So that is it. So that is how our insert function is working, and I hope there is no compilation error. So what is the time complexity? So when we are checking for our So I think the time complexity is almost similar because when we are adding all the strings, so it is taking time complexity O of n, and when we are checking for all the strings, it is also taking time complexity O of n. And also for all the strings, we have to traverse one by one. So here in insert method we are traversing, and here in our is present method we are traversing. So in both the methods, we are traversing in our string, and this is our time complexity of n. So n into length of string. So time complexity is almost similar, but it is optimized due to this repetitive case. And we also have to learn a new concept today. That was our string. That was our try. So that is it about today, everyone. If you learned a new concept today, then let me know in the comment section if you understand this whole thing or not. So what is this thing, and why are we using here is and variable, and what is this whole array thing? So if you understand this concept, then do like this video and share this, and also subscribe to our channel so you will get this solution in our DS repository. So I will just paste this. So thank you for watching.